Hello pre-calculus students, and welcome to a video on some applications of piecewise defined functions. So this is lesson 5-3b, and we're going to look at some piecewise defined functions here, just two examples. So let's take a minute and read the first example. Let's read it carefully. And so this is a parking lot problem, and so a parking lot charges a flat fee of $10 if you park there for 1 hour or less. So as soon as you enter, you pay the $10, and as long as you don't go over an hour, you're paying $10. Okay, if you go over the first hour, or you start into the second hour, you're going to get an additional $6 charge for the second hour. If you exceed 2 hours, an additional $4 is charged, and every $4 for every hour after that. And then there's this maximum of 32. So you can't go over. You can't go over $32. It doesn't matter if you stay there for 20 hours because it would be a lot more money if you did that. All right. So what I'm going to do. So let's continue. So I mean, this is just sort of a domain restriction right here that you cannot stay for more than 24 hours. So it kind of limits the problem a little bit. If you do, your car will be towed, and that's a totally different problem. Okay, don't do that. All right. So what's the charge for parking? So what we're going to do is we're going to look at the first couple of them, A and B, and then we're going to just go ahead and make the piecewise function itself. We're just going to write it out, and then we'll answer the rest of the questions C and D. All right, so first of all, if you stay for 45 minutes, that's still part of the first hour, so you're just going to get the $10 charge. Okay. If you stay for more than an hour, that's where you get, so that's an hour or less is $10. If you go over the first hour, an additional $6. And as long as you don't get over 2 hours, you're just going to get that 6. So this will be the 10 plus the 6, that's $16. Okay, let's write this out now as a piecewise function, and then we're going to come back and answer these other two. So we know that the charge will be, now f of x is going to be the amount, the dollar amount, and x, so here f of x will be dollars, and x will be hours. So we're looking at an input of hours, how many hours are you there, and an output of dollars. So this one would be 3/4, this one would be 1.5 if we're going to use the function here. Okay, so let's look. So we're going to pay $10 whenever we're there from between 0 and 1 hours. So as long as x, as soon as you enter, you pay the money. So as long as x is greater than 0, if you don't enter, you don't pay the money. And up to 1. And that, I know that I'm including the 1 because it says right here, 1 hour or less. So it includes 1 hour and it includes everything less than an hour. That's what I have here. All right, as soon as you go over an hour, you're charged another $6. So that's going to be 16 whenever x is greater than 1 and up to 2. And that's for the whole second hour. And then it's not until you exceed the second hour that you get charged again. So we're going to include the 2. And we're going to include all the endpoints following the same pattern. Now the next hour you're charged $4 more, so it goes up to 20. And that's when x is now greater than 2 and up to 3, including the third hour. So not until you break that third hour that it gets another $4. So you go up to 24. When you are between, when you're staying there between 3 and 4 hours, so 3 and 4, okay, greater than 3, up to and including 4. Then it goes up to $28 when you go over 4 hours, so if you go there from 4 hours to 5 hours, and there it is, so anything greater than 4 and less than or equal to 5. And as soon as you go over 5 hours, you get up to the maximum, which is 32. So this is whenever x is greater than 5 hours, but you can't stay for more than 24 hours. So more than 24 hours you're towed, so you can stay for exactly 24 hours. So 5 to 24 hours, you're going to pay the fee of $32. Okay, so there's the function. Remember, different rule for each part of the domain. And now let's answer these other questions. For 4 hours, this one is including 4, so it's going to be a $24 charge. When you get to the 10th hour, you're over 5, you're between 5 and 24, so it's going to be that $32 charge. Okay, so now let's graph this piecewise function. And notice that this is a bunch of horizontal lines. These are just horizontal line segments in different parts of the domain. So we want to make sure we get the essential parts of the domain. It's changing every unit up to 5, and then it's not going to do much between 5 and 24. So there's no reason to go all the way up to 24 with the x's. We can just go up to maybe 10. That would be good. So let's see how far we go. If we kind of try to space it evenly, this would be, these are hours. Remember, x is the number of hours. We can put that down here. So 1 hour, and then again, try to evenly space it. 2, 3, 4, 5, 6. That's good enough. I didn't get 10, but I tried to get them evenly spaced. Okay, and then this y-axis, or f of x, this is going to be dollars, right? This is the amount of dollars that you spend, so dollars. And we know that that maxes at 30 or 32, so we're going to make our graph to be able to represent that. So let's just see if I put a 32 up here, since I know that that's the max. I can kind of estimate what half of that is and just make that 16. This is just one way to make an axis when you have real numbers. And then half of this would be 8. And then halfway here would be 24. And is that good enough? I may as well just put lines at the other ones, and I don't have to write the numbers in. But at least I'll be able to graph maybe a little bit more accurately. All right, so let's make our graph. So we have, if this is 8 and this is 12, then 10 would be right about halfway between there. So 10 from 0 to 1. So are we going to include 0? No, because if you don't go in there at all, you're not going to pay anything. And we are going to include 1. And that's a horizontal line segment. Okay, and that's the point 1, 10, represented by the input here, the input of 1 and the output of 10. All right, let's keep on going here. So if we go between 1 hour and 2 hours, we know that it's going to jump up to 16. So that's right here. That's where that step will go. If we're at exactly 1 hour, we're not going to pay $16. We're going to pay $10. But anything else between 1 and 2 hours, up to and including 2, we're going to pay $16. So there's the second step. And this is a hole at 116. That's a hole there. And this is a point at 216. Okay, and let's just keep going. So from 2 hours to 3 hours, it's going to jump up to 20. 16, 20, that's exactly, did I make my scale right? I did, yeah, so it's going to jump up to 20. So here, this is 16, this is exactly 20. So it's going to be right about there. And it's going to go to right about there. And I'm just going to fill the rest of this in. Okay, so there's the rest of the graph. Notice that, there's always a hole on the left, there's always a point on the right. This just means that we're kind of distorting the graph here, and we're skipping all the way over to 24, even though that's just a little bit past 7, just because we're running out of room on the graph. But that will be the end point. And if you stay exactly 24 hours, you pay $32, and then there's nothing else to find after 24 hours. We don't know what the towing charge will be. It's not part of the garage structure. Okay, this is similar to a greatest integer function. But there's not really, it's a piecewise integer function, so it is a piecewise step function. Okay? Okay, let's look at a second example. Lisa starts babysitting at 4 p.m. She makes $8 an hour before midnight, and then $10 an hour after midnight. Now, it's a little bit iffy here because it doesn't say what happens if she stops at exactly midnight. We're just going to not worry about that detail too much. Okay, so what she does, how many hours can she work between 4 p.m. and midnight? 8 hours, right? So for those first 8 hours, she's going to make $8 an hour. So if we let x equal the number of hours and f of x equal her pay. By the way, there's a little typo here. What is does. I think we should say, what does Lisa make if she works until and then certain times? All right, we let f of x equal her pay. which is going to be $8 an hour times the number of hours, so that's just going to be 8x, right? $8 times the number of hours. But things change at midnight. Okay, so let's write out a piecewise function. Actually, let's answer these questions first. Let's answer part A first. So in part A, it says what happens if she works till 10 p.m. Well, if she works till 10 p.m., then x equals 6, and she'll just make 6 times 8, or $48. What if she works till midnight? Okay, then she's worked for 8 hours. So that would mean x equals 8, and she makes 8 times 8, which is $64. Okay, if she works till 2 a.m., she makes the $64, but now she gets a raise for those last 2 hours. So if x equals 10 to get to 2 a.m., right? If x equals 10 hours of work, she would get the $64 plus $2 at 2 hours, at $10 per hour. So plus 2 times 10, that's another 20, so she would make $84. Now let's see how we can write this into a piecewise defined function. Okay, so let's say, we're writing the function now, so we've got f of x equals, and we have to put this sort of fancy bracket there, and we've established pretty much that for the first 8 hours up to midnight, she's going to make 8 times the number of hours, $8 per hour. So she's going to make 8x whenever x is between 0 and 8. So whenever x is, as soon as she starts, and up to and including, like I said, we're not going to worry about that detail too much, but the first 8 hours of work. Okay, remember, x is the number of hours. All right? As soon as she goes over 8 hours, she's already got, as soon as it passes midnight, she's already got $64. And now she's going to make $10 an hour. But it's not 10x. Because we don't want to count the original ones again and give her pay for those first 8 hours. We only want to count the hours after the 8th hour. So it's going to be actually x minus 8. Okay? And that's for anything over 8 hours. Now, does that work? Does that work for the number that we got here? So let's say that we plug in a 10 to this function. So if we find f of 10, now that we have a function, we can try this. F of 10 would be using this rule right here, right? It's more than 8. So we would say 64 plus 10 times 10 minus 8, which is exactly what we did. We did 2 times 10, right? Okay, so the function works. Now let's just graph it out. Okay, so I've made a graph, since this isn't on graph paper. I just wanted to take a minute and do that. And what I need is the endpoints and end holes, just like we always have found when we're graphing piecewise functions. So let's plot the endpoints and holes here. Let's first find them. Okay, so I just plugged in the 0 here, and I know that there's a hole at 0, 0, so this is actually where it starts. And then there's a point at 864, because if you plug in 8 here, you get 64. And then I did one more point just so I could finish up this other line, because I know there's 2 different rules here. And I just used the fact that we already knew that when the input is 10, the output is 84. So I'm going to look at the point 1084. Now my graph's kind of not that neat, but I plotted these points in a way that at least you'd be able to see the point. And that's it. That is that the function changes direction and gets a little bit steeper after midnight, right? So after 8 hours, the function gets a little bit steeper, and I just wanted to show that, so that would be the graph of the piecewise function. Okay, I hope you found this video helpful.